Hi everyone. In this video, we are going to see about the hazard management for EV system. So let us detailedly discuss in the upcoming slides. So hazard management, it is one of the key thing when it involves the high voltage of current. Since in EVs, we know that for running the vehicle, we are using the electric power. So the amount of electric energy evolved or involved in this process is very high when we compare to the existing IC engine, where we use the electric vehicle only for a limited components like lighting system and like ignition system, etc. Right. So introduction to EV as such, it includes the first we need to understand the EV hazard. So normally our EV represents the unique hazards due to their high voltage system, battery technologies, and electric drivetrains. So in conventional IC engine, when we compare the EV with the conventional IC engine, the whole engine is replaced by the batteries, motors. Right. So for making the vehicle, whole vehicle to move, we need a, high amount of current. So we need to follow some basic safety steps in order to save ourselves from the high voltage currents. And the types of hazards in EVs includes first through electrical, and second thing is through thermal runaway. When the battery starts leaking or when the battery is damaged, there will be a thermal runaway, and later it will lead to the blast. So this is also one of the hazards that we need to consider in case of EV, fire risk, and the mechanical failures. So comparing to the other two, the thermal runaway and electric shock, the severity of these two hazard is more. In hazard management procedure, we need to follow proper hazard management. It enhances user protection, the acceptance of EV technology in markets. Since in India or in some other countries, they are very afraid to adopt the EV due to this kind of issues. So when we address these issues, then the EV can reach the market in a higher rate, and the amount of users can be increased rapidly. So in empathy part, the thing is that first is the identifying a risk and evaluating risk and document findings. So the first, as we said, discussed in the earlier side, there may be many risk factors has been involved while we using the EVs. It is the responsibility of the engineer who is designing the vehicle to collect the what are the kind of risks that has been possible in the case of EVs, like conducting assessment or getting the feedbacks, and with that we can have some conclusion that what are things that can be used. So the empathy can be done in customer preview, so that the expectation of customer can be got. And the evaluating, and after identifying, we need to evaluate what are the risk factors are affecting, and what we need to address, and what are the risk is high, so we need to prioritize and we need to proceed according to that. And we need to maintain a proper document for the risk identifier, and need to give solution accordingly. And safety standards normally in existing ISO 26262 has been used for the functional safety, and then IEC 61851 for charging infrastructure. So these are some existing standards. So a standard regulation that need to be followed for each and every time, so that the hazard management can be done in an effective way. And in ongoing updates, so we need to stay informed on the updates related to the safety standards and regulations as the EV technologies in defined part. So we need to make this particular vehicle in a robust system design, so implement more safety features in order to prevent failures, and also prevent the passengers from the collapse or mishaps, and we need to prevent the passengers. And in some kind of safety systems, we need to predict the failures in before it happens. And component testing, so we need to test each and every batteries, motors there. We need to regularly maintain the working, so that we can prevent the problems. And the design should be based upon the user centric, as our designs thinking teaches. So it should be user centric design so that it can reach more customers and can reduce the risk of the real time applications. So we can develop the resource plans with the collected empathies, and we can conduct some training sessions for the mechanics or the other people related to the EVs, so that during the hazard time they can handle the situation in an effective way. Because so far in 30 years to 30 to 40 years we have faced the problems related to the IC engines. When the IC engine got fire, we know how to may solve that issue, but it is not in the same case of the EV. So a proper training that need to be given to the mechanic and also to the user, so that they can handle the situation during the this kind of problems. So regular maintenance, the inspection checklist, and feedback mechanism. So these are the things that can be followed in order to have a good hazard management system. So some of the technical things includes battery management system BMS. It continuously monitors the battery health and the battery charging stage, and also it measures the temperature. And with the help of this, that we can monitor the battery health, and we can act accordingly to the input of this, so that we can prevent big problems in EVs. So this is the overall mind map of our PPT. So far we have discussed about the introduction importance, the risk assessment process, safety standards and regulations, the design strategies, an emergency response planning, the maintenance and inspection protocol, and about the BMS we have seen, the consumer education awareness, and future trends and conclusions. So in future trends, the emerging technologies will come into the act, like the integration of AI and IoT on the hazard on this particular hazard management, so that it will be easy for the user to access, and easy for it makes the user to monitor the system in an effective way. And this is also a sustainable practice and continuous improvement needed in the EV industry to meet out this particular assignments. So that's all about this video. Thanks for watching my video. Thank you.